welcome back. I hope everybody had a good holiday period. And I'm going to go ahead and create a couple lessons in case some of you want to get ahead of the game because we do have our test coming up shortly after we get back. Okay. Well, today we're going to talk about Module 4, Lesson 11. And this standard is MAFS 5 NF26. And it's where you solve real word problems, word problems, involving multiplication of fractions and mixed numbers using visual fraction models or equations to represent the problem. Now, for this lesson in Lesson 11, our objective is about a difficulty 4, and it's where you will be able to solve fraction word problems involving addition, subtraction, and multiplication. And you're not going to know which operation, you're just going to have to read the problem to determine that. Now, in today's lesson, I'm going to model 4 different word problems, and you're going to see that I really need to draw and represent the problem to keep track of it. Okay, let's take a look at problem 1. Kim and Courtney share a 16-ounce box of cereal. By the end of the week, Kim has eaten 3/8 of the box. Courtney has eaten 1/4 of the box of cereal. What fraction of the box is left? All right, so let's start by just identifying some pertinent information. It says they share a 16-ounce box of cereal. By the end of the week, Kim has eaten 3/8 of the box. That's impertinent information. Courtney has eaten 1/4 of the box, and it wants to know what fraction of the box is left. Now that is important, okay, as far as what fraction of the box is left. It doesn't want to know how much they ate, it wants to know what fraction is left. And up here where it says 16 ounce, that's a distractor, because that 16 ounce is an exact measurement, and we want to know how much, just what fraction of the box is left. So we're talking about 1 box. So now I'm going to draw something to represent the problem. So first, if I draw a box, a rectangle, and I'm going to say this is 1 box, because we want to know a fraction of the box, so that's just 1 box of cereal. Now it says Kim has eaten 3/8 of the box, so I'm going to go ahead and split these into 8s. There's halves, quarters, and now I'm taking them to 8s. So it says Kim has eaten 3/8. So there's 3/8 that were eaten. And that was eaten by Kim. That says Courtney has eaten 1/4. Well, if we look at this, I know that if I were to split this back into quarters, because that's what I initially split it into here, were quarters, I can see that 2/8 equal 1/4. So I know now that right here that 2/8 being 1/4. And this is what Courtney ate. Now that has this here as what is left of the box. And you can see we have them in 8s already, so we know that's 3/8 is left of the box. See, by doing the problem and using a tape diagram, we kind of solve the problem as we go along. Let's try another one. In problem 2, it says Mathilde, I think it's Mathilde, has 20 pints of green paint. She uses 2/5 of it to paint landscape and 3/10 of it while painting a clover. She decides for her next painting she will need 14 pints of green paint. How much more paint will she need to buy? So this is a 2-part problem. So let's identify first what the important information is. And first off, we know that she starts off with 20 pints of paint. She uses 2/5 of it to paint the landscape, 3/10 to paint the clover. She decides at her next painting she will need 14 pints. How much more paint does she need to buy? So I've got to find out first on this is how much she used of the original. So let's start with a tape diagram. And let's figure out first off what was used of the original 20 pints. So here's 20 pints. And I can see it says fifths and tenths. So you know what? I'm going to split it up into fifths first. And I'm going to use different colors. That way it'd be easier for me because I know that's 1/5, 2/5, 3/5, 4 and 5/5. And you know what? And it says here that they use 2/5. So there's 2/5 that was used for landscape. Now it says tenths, that she used 3/10 for painting a clover. Well, one thing I know is that if I take a fifth and I split it in half, I have 2/10. Now I can see that it says she used 3/10, and that was used for the clover. That means this is what was left. And we can see by looking at it, she had 3/10 of a pint left. Now, let's take a look. The second part says for the next project, she is going to need 14 pints. And I can see here that we have 3/10 left. So this is what has to be bought. So I can see by this here, I've got 14 pints. If I subtract the 3/10 from that, of what I have left, I should be able to solve what I need to buy. Well, I can see I can add 3/7 to get a whole. So that would make it 13. So I know I'm going to have 7/10, and it's going to be 13 7/10. Because if I add 3/10 and 7/10, I get one whole plus 13 is 14. So I need to buy 13 7/10 pints. Okay, problem 3. Jack and Jill and Bill each carried 48-ounce bucket full of water down the hill. By the time they reached the bottom, Jack's bucket was only 3/4 full. Jill's was 2/3 full, and Bill's was 1/6 full. How much water did they spill altogether? Now let's identify the important information. So, start off, they all had 48-ounce bucket. And Jack's bucket was 3/4 full when he got down. Jill's was 2/3 full, and Bill's was 1/6 full. So now let's go ahead and build us 3 tape diagrams to represent each of the buckets. So this one here, and we're going to say this is Jack's, okay? And we know it's 48 ounces. It's not asking what fraction, it's asking exactly how much they spilled. So that's 48 ounces. And we can see it says that he was only 3/4 full. So we're going to split this into quarters. So this here is the amount that was full. So this is what he spilt. So let's go ahead and draw the next one. And this one here was Jack. Now let's do Jill. Now on Jill's, same thing. She started out with 48 ounces on top. And we're just representing the problem right now. And hers says thirds. So we're going to split it as thirds. And it says it was 2/3 full. That means 1/3 was spilt. And the last one here is going to be Bill. And once again, he also had 48 ounces. But this one, he said he had 6. There's 6. And he said it was 1/6 full. And that means he spilled 5/6 of the bucket. And let me go and write that 1/3 and 1/4. So I can see now, let's go back to Jack. He spilled 1/4 of the bucket. So 1/4 of 48 ounces. So 1/4 of 48. And remember when we were talking about that actually means multiplication. So 1/4 times 48 would equal 48 over 4. And I know that 48 divided by 4 is going to give me 12. So he had 12 ounces left. Well, actually, that's what he spilled. He spilled 12 ounces. I noticed that. We went to seeing what was spilled because that's what's being asked. Now over here it says Jill spilled 1/3, and she spilled 1/3 of 48. Now once again, that means 1/3 times 48 would equals 48 over 3, which 48 goes into, actually 3 goes into 48. Let's try that. 48 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. We got 18. 3 going to 18 6 times. 6 times 3 is 18. So we can see this was 16 ounces. So far we have 12 ounces plus 16 ounces that were spilled. And we're still looking for Bill's now. Now, according to Bill's, he said he spilled 5/6 of 48. Now, this is where we can do something interesting, which 5 times 48 over 6. And we know 6 will go into 6 one time. 6 goes into 48 8 times. And that leaves us 5 times 8 over 1, which is 5 times 8 is 40. Divided by 1 equals 40. So we know now Bill spilled 40 ounces. Now all we have to do is add them up. I can add up any way I want. I know 12 plus 16 is going to give me 28 ounce plus what Bill spilled, which is 40 ounce. So in total, they spilled 68 ounces. Okay, our last problem here has, let me get my pen up. My pen's giving me some problem. I don't know why it's giving me a problem here. There we go. Miss Diaz makes 5 dozen cookies for her class. 1/9 of her students are absent the day she brings the cookies. If she shares the cookies among the students who are present, how many cookies will each student get? Let's identify some important information first. She has 5 dozen cookies. And 1/9 of her class, which is 27 students, are absent. Then she shares the cookies equally among the students who are present. We want to know how many cookies will each student get. All right, so this is going to be a 2-step problem. We're going to have to start by solving it and see how many students are actually in the class right now. Because we know that our normal class is 27 students. But she says 1/9 are absent. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And this group right here is absent. So I know then that 8/9 of our students are present. So I want to know what 8/9 of 27 is? Oh, you remember 8/9 of means multiplication. So now I can rewrite this as 8 times 27 over 9. I like to write it like that because now I know that 9 can go into 9 one time and 9 goes into 27 three times, which leaves us with 8 times 3 over 1, which equals 24 over 1, which equals 24. So she actually has 24 students that day to share the cookie. Now let's come over here for the cookies. Now it says she has 5 dozen. Well, I know there's 12 in a dozen times 5. That's going to give me 60. So our total is 60 cookies. Now I'm not going to break this up into 24. What I'm doing, we want to know how much each one get. So I'm going to go like this. And I know there's 24 of them. That's a quick way to use the tape diagram to represent your problem. And we can see that means that 60 divided by 24. And I like to write that as a fraction because 60 24ths. And now I can decode that. I can see 6 is a common factor. So I'm going to decode this as 6 times 10. And it's 6 times 4 is 24. And that allowed me to take out the commons. Now I got 10 fourths, which I know 4 will go into 10 2 times and leave me 2 fourths. So now there's 2 and 2/4 cookies each. Well, that doesn't sound right because we don't have 2/4 cookies, but I can decode that because I know 2/4 is actually equal to 2 times 1 and 2 times 2 equals 4. So now I know each one will get 2 1/2 cookies. Now let's see, I want to double check that because we did multiple steps there. So we know we had 24 students. And I'm going to multiply that by 2 1/2 cookies each. Well, I know 2 times 24 is going to give me 48, and half of 24 is going to give me 12, which equals 60 cookies. It checks. All right, these multi-step problems are not that difficult if you draw them. Remember, just like when we do them in class, represent the problem with a tape diagram. Fill in the known information, see what you need to solve for, and then always, if possible, check your work. All right, I look forward to seeing you in January 6th. Have a good day.